Hey guys, and welcome to today's MCAT question of the day. As always, today we're going to be working through one of the many MCAT practice problems found at MCATselfprep.com, the home of the free MCAT prep course. I'm Dalton, a 100th percentile MCAT tutor, and today I'll be working through this problem with you as though you're one of my private tutoring students. Today's practice problem comes from the end of lesson mastery quiz in lesson 11 of the Physics 1 module. Be sure to hit pause and try this problem for yourself before watching my explanation. All right, in cases like this, when we're dealing with the force that a magnetic field is exerting on a charged particle, this is a great equation to know. This is what we want to know. And I know this can look a little bit intimidating to memorize, but the good news is that a lot of the physics equations that we have to memorize for the MCAT have a lot of overlap with the variables. So if we can remember certain key variables, it'll help us better remember and use lots of different equations. For instance, you probably have heard before that capital F is going to be force. That's referring to this force right here, this red arrow, that the field is exerting on the particle. Q is almost always going to be charge, that lowercase q. So that's the charge of the particle. V, as you know, is almost always velocity. And so velocity in this case makes sense, the velocity of the particle. That's what's moving in this problem. Now this uppercase B, that's not quite as common, but you actually will see that a decent amount. Uppercase B refers to the strength of the magnetic field. And finally, sine theta. We know theta is an angle. We're taking the sine of some angle. So what angle are we dealing with? Well, in cases like this, we're dealing with this angle right here between the direction of the field and the velocity of the charged particle. So it's this angle right here, almost perpendicular in this case, where you can see the field's coming down and the particle's moving out, maybe left. This is the angle right here that we're concerned about. And the reason we're concerned about it is because this is actually really interesting. The closer to perpendicular this particle is moving relative to the direction of the field, the more force is going to be exerted on it. So if it's moving parallel or even anti-parallel, it's actually the force is going to be zero. No force is going to be exerted on it by that field. But the closer it gets to perpendicular, the stronger that force is going to be. Now, one other good thing worth noting, this is a really cool image. It's nice. It's easy to see. Everything's in 3D. That's part of the reason I picked it. But a lot of the times you won't see images like this. Rather, you'll see it drawn like this. You might have, for instance, the force. You might have the velocity. We've got these two dimensions. That's pretty easy so far. What do we do with that third dimension of the field? Well, a lot of the times they'll draw it like this. They'll draw circles. And if it's going away from you, they'll do an X. Like if we were up here looking down, it was moving away from us, they do an X. On the other hand, if it's coming towards us, they'll do a circle with a dot, which makes sense because if you think about like a bow and arrow, with the arrow, we've got all these feathers on the back. That's the X. We're looking at the arrow go away. Whereas here on the front end, there's just this point. And so we only see a point. That means it's coming towards us. Now that we know that, let's go back to the question and see what we can figure out. All right, so what has the question already told us? We know that we're dealing with an electron right here. We know the strength of the magnetic field. That's going to be our uppercase B, right? And we know the magnetic force, that uppercase F. It's going to be zero. Well, this is really interesting. That's probably the most helpful thing we know is because if this side is zero, if this F is going to be zero, and all these things are being multiplied together, then at least one of them should be zero in order to make this side zero. That would make sense. So let's go ahead. We want to know which of these conclusions is valid. Which of these things could be possible? We'll start with the top. The magnitude of the electron's charge was too small for it to experience a force by the magnetic field. Well, we know based on this equation that doesn't super check out because even if this Q, this charge, was a super, super small value, yeah, we definitely have a super, super small F on the left side when we multiplied everything together, but it wouldn't be zero. A small number wouldn't give us zero there. So this is going to be incorrect. This third option down here, it actually has the same problem. It's saying the magnetic field was not strong enough to apply a force that would be felt by the electron. Well, even if B is really little, it's still going to create some force, just a small force. And then finally, you remember this from our earlier discussion. The electron's velocity was perpendicular to the magnetic field. That's dealing with this here. Perpendicular, theta would be 90 degrees. Sine of theta is going to be a really big number though. Now, if we had sine of 0 or sine of 180, we would get a 0 there. And that makes sense because if we're going parallel or anti-parallel to the field, there isn't going to be any force. But it's important to recognize here that because this is perpendicular, the opposite's going to be happening. Rather than making the force 0, that actually makes it a much stronger force. So we're going to go ahead and cross this off. That leaves our last option here. The electron was not moving. And this final answer option is going to be the one that makes the most sense. Because think about it. If our initial velocity is 0, we plug a 0 in for this B. no matter what all these other ones are, we're going to end up getting 0 on the left side. So that actually makes a lot of sense. Let's check it out. Awesome. Perfect. If you enjoyed this MCAT question of the day, be sure to give it a like. For more MCAT questions of the day, be sure to subscribe to this YouTube channel and enroll in our free MCAT prep course found at mcatselfprep.com. Now, if you're really looking to maximize your MCAT score, be sure to check out our elite tutoring services and request a free consultation with any of our available tutors. We'd love to chat with you about your situation and how we can help you maximize your MCAT score. Look forward to hearing from you, and we'll see you next time. See ya.